Yeah, good afternoon from here. I'm Olakunle Sansa, a doctoral research fellow, a PhD fellow at the International Institute of Agriculture, Tropical Agriculture, IITA, here in Nigeria. Yeah, I'm a PhD student in plant breeding and genetics.
Mhm.
Yeah, I think
Okay,
that's,
so you
that's
are from Nigeria. You are in the plant genetics.
yes, plant breeding and genetics, yes.
Okay, great. And how you're finding this workshop that which you are attending? Did you
Yeah,
find it
it's
interesting?
very interesting and very impactful.
All right. Thank you.
Yeah, thank you. Thank you.
All right. Thank you. Now I will be making spotlight another person now.
Good
Yeah,
evening,
madam.
everyone.
Yes.
This is Rupavati from Tamil Nadu,
Mhm.
India. Uh, I'm a special educator and a PhD scholar doing my research in special education now.
Okay. And what is the field you are working with right now? Your
Uh,
research.
Specific to skill development for children with intellectual and developmental disorder.
Wonderful, wonderful. And how did you find this workshop?
Very useful, very useful. It'll be definitely contributing for my research work. It's very useful.
Thank you. Okay, now I'll replace with Chandni Singh ji.
Hello everyone, I'm Chani Singh Nokar. Hello everyone, I'm Chani Singh Nakarmi from Nepal. I'm a recent MPH graduate from BP Koirala Institute of Health Sciences, and I'm finding this workshop very interesting.
Wonderful. Thank you. Karma.
Hello, I'm Karma Chu. I'm from Bhutan. And currently I'm working as a researcher here in one of the FDA company. So I find this workshop very informative, and so many things are new to me, and I hope I'll be learning so much more hereafter in these 6 days of workshop. So I think that's it lah.
Thank you, Karma. Thank you. Okay, now I'll go to the another participant, Mr. Saharul Islam.
Yes, hello everyone. Good morning. Sorry, good evening everyone. Because I am from Malaysia
Very good.
and I am a PhD student actually, and I have found this workshop. It is very helpful and it is very rich content. And maybe trainer is a very resource person. So I think everybody would be knowledgeable after complete the 6 days workshop. Inshallah. Thank you.
Thank
Thank
you.
you.
Thank you. I'll replace with Mayat.
Yes, good evening, everyone. I am Yamon, and I'm from Myanmar, and I'm working at a research institute, and I think this workshop will help me build my skill for the data analysis and help me to get some skill for the data analysis. Yeah, thank you for letting me join that workshop.
Great.
Nice to see
So
you.
where are you from? Basically, I didn't get that. Where are you from?
I'm from Myanmar.
Myanmar.
Myanmar,
Where it is located? It's a country or
Southeast Asia.
Southeast
It's quite,
Asia?
yeah, quite near to Thailand, Myanmar, Malaysia.
Myanmar.
Yeah,
Okay.
yeah,
Okay.
Myanmar.
Good,
Yeah.
good, 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 good. Sorry. I didn't able to get the Myanmar. Okay. We had a few participants in past also. Nice.
Mm,
Thank you very much.
mm,
Thank you very
Thank
much.
you.
Okay, I'll go to now Mr. Anil. Yeah, Mr. Anil. Looks like you're not ready. Okay. I replace with another participants. Mr. Glenn Gomez.
Yeah, my name is Glenn, and I am from Bombay, but currently working in Jeddah, Saudi Arabia. I am working as a national sales manager in one of the FMCG companies here for the past 15, 20 years. And for me, data analysis is very important because day to day we are working in so much of data, being in FMCG industry. And for me, this yesterday's course was very useful. And even the tutor was explaining from this basic scratch level. So it's very useful for me. Thank you.
Thank you very much. Thank you very much. Now I'll go to another participants. Mr. Vinod.
Namaste and good evening, everyone. I'm Binod Ravi from Nepal. I'm recent graduate, MSc in Statistics from Tribhuvan University. I hope this training will enhance my data analysis. Thank you.
Thank you. Thank you very much. Thank you. Okay. Sorry, I will get your name. Just tell your name, please. I'm really sorry that I'm not able to get.
Okay. My name is Gatarila Pierre Kobes, a research fellow at the International Institute of Tropical Agriculture.
Okay. And you are from Nigeria?
From Rwanda.
Rwanda. Okay.
Yes.
And how did you find this workshop?
This workshop is very important. I'm a plant breeder, and this one will help me to do analysis and have a good results. So this workshop is very, very important for me.
Wonderful. Okay. Now I'll replace spotlight with another participants, Subhangini.
Good evening, everyone. My name is Shubhashini, and I'm currently pursuing MBA from Vinoba Bhave University in specialization of human resource and finance. So this workshop has been very much important for me. The first day was very much interesting. Got to learn so many insights from this workshop. So I am sure this will help me in my future growth and success of the company.
Thank you. Thank you very much. Thank you. So the idea, that to introduce, that to each one is that we can, that have a little bit knowledge about each other because we are co-participants and we are learning, and also to know each other. Maybe we are useful in each other's life also professionally, because let's say that somebody is working in the same industry, let's say in a biotech, or maybe in FMCG, or maybe doing research. So today we have introduced, let's say 10-12 people. Maybe tomorrow again we'll do the same practice to introduce other people also. So you never know, sometimes it's very good to have a meeting people from around the world and helping each other. So the basic concept of Cypher Analytica is that help each other. The concept behind and our mission and vision is same, like that how much we can help from our knowledge. So that's why in pandemic we have, as I said yesterday, that we have made it a free workshop. The course fees was that waived off. So that is the main idea, that a maximum knowledge can go to the maximum people. We know that lots of financial crisis we all may be facing, and this time it is time that the world need help. So it's time for help each other. So that's why me and Dr. Pramar and our team decided to that make the waiver of all the workshop. Not only this workshop, any workshop we are doing, we did in last 8-9 months, we made it free. That much we can do for the world, because you get so many things from the society, from the world, from the country. So you give that, and that the knowledge is the best thing to give. So that's how Dr. Parmar is doing, and we are trying to help each other. So thank you very much, all of you, uh, to joining this workshop. And tomorrow again we will be introduce each other. See that you might be get connected to each other to see that if it is will be helpful for you. So those who are not get introduced today, don't worry. Tomorrow again we'll meeting each other. All right. See, this is a very global platform where people from different part of the world participating. It's not that people from, you will see that's very global. We call it global. Why? Because you meet people from India, people from Bhutan, from Myanmar, from Nigeria, from Europe, people who is Indian who is working outside India, from different industries, educator. So this is very global platform, very global platform, and that's the our brand. That's how we introduce ourselves. We are global. We are not fixed with one thing. So everybody is open to learn here. So I welcome once again Dr. Parmar here. Sir, you there?
Yes, sir.
Thank you very much, sir.
Thank you.
We can start the session, sir.
Yes, sir. Thanks, Mukeshji. Welcome, everyone. Let's continue the session. Let me share my screen with you first. Am I audible to you all?
Yes, sir.
Okay, nice. And my screen is visible to you? Yes. So let's continue the session where we have left yesterday. Yesterday we have covered that the measure of dispersion we were studying, and just a moment. First, I select my few favorite colors from here. Just a minute. I just choose few colors from here and then we start it. Okay. Yesterday we have covered that the measure of dispersion we were studying. I just changed the brush also, so it could be better for you. Measure of dispersion we have studied yesterday. And in this measure of dispersion, we have studied about the spreadness. Okay. And today we will cover the scatterness. Measure of scatterness. Okay. This we cover today. And the first I will explain the concept. Hypothetically, visually, I will explain this concept. And just I put few points here for better understanding it. I'm hypothetically making this for the data. These are the data points we have. Suppose, okay, we have so many data points, and these data points are like we could say that it is the x1, This is our x2, x3, x4, x5, and up to xn we have n data points we have here, and we have some measure of center tendency here in this. Along with these data points, we have mean, we have somewhere median, we have somewhere mode. Okay, so we have several data points, n data points, and we have all three measure of filtering tendency. And what we do here, as we know that the average scatterness I explained you yesterday, but average scatterness is not a good measure. So then the statistician or the mathematician decided we should take the deviation from the center tendency of the data points, and then we find out the average of it, and that would be a good measure of dispersion of this in the perspective of scatterness. So they have decided it, and they have tried to do it with like in this way. They have taken the deviation from x bar to x1 to x bar, then other point, then other point. In this way, they have taken the deviation of each point. Okay. I'm not drawing the all one, but few I have drawn it. They have taken this deviation from the all points from deviation from mean of each data points. So what they have done it, when you, I just change the color. If you get the deviation of a data points from mean, what summation you will get here? Can somebody explain? If I get the summation of this, what I will get? If I get the summation of deviation from mean of the data points, actual mean, what I will get? Yes. Yes. Binod is correct. Sudeep is also correct. He always get this summation would be 0. So how we could get out the mean of this? So what they have done, they have taken the absolute value. So absolute value does mean that whatever the negative deviation, they convert them in positive and then they edit. Okay. And then it divide by n. So this is the mean of absolute deviation. And this is the absolute deviation because we have converted this in positive and we are dividing it by n. So this is the mean of absolute deviation. So it is called the mean absolute deviation. Mean absolute deviation. Or we could say that it is the delta x bar denoted by this symbol. So the mean absolute deviation through mean. Similarly, we could find out this deviation through the median also of the each data points, each and every data points. So at that moment, what we get, summation of xi minus me over n, because we get the, just a moment, I just Okay. Yes, why it is 0, I explain you. Just a moment. Okay, now audio is clear. Yes. Okay, okay. Because this mic is too much sensitive to it catch the voice from far. Someone is the other room, it catch the voice. So how we get this 0, I explain you. I am taking few data points. I am taking 2, 3, 7, 9, and 4. So what would be the sum of this? Yes, 2, 3, 5, 9, 4. The sum would be 2, 3, 5, 5, 7, 12.
25.
25, correct. It would be 25. And we find out the mean of this. So we divide how many numbers are there? 5. So we divide by 5. We get the mean 5. Got it? So what we are doing, this is our x, 2, 3, 7, 9, and 4. And this we are taking the x minus x bar. Got it? So it is the 2 minus 5. It is 3 minus 5. It is 7 minus 5. It is 9 minus 5. It is 4 minus 5. And we see what we get here. We see here minus 3, we get here minus 2, we get here plus 2, we get here plus 4, we get here minus 1. And we add on this minus, so we get the negative 6, and we add on this positive, we get the positive 6. So if we get the summation of this, what we get here? Yes. Manpreet, you got it? Now? Karma? Okay. So whenever we add we add the deviation from the actual mean, we always get it 0. It may be from the median, it may be from the, so that we get always 0. So why we are getting the absolute value? We are converting this negative in positive. So minus 3 we will get 3, minus 2 we will get 2, 2 plus 2 is 2 already, plus 4 is 4, minus 1 is 1. And here we get some value of deviation. Got it? Basically, the definition of the deviation is always bidirectional. It is not a single directional. You see in the pendulum, it deviates both the sides. Okay? Got it? So why we are taking the positive value most? So here if we write the mean absolute deviation by median, and finally we get through mode also. Mode we represent by Z, and that would be like this. Got it? So we have the mean absolute deviation, 3 mean absolute deviation. One is through mean, second is through median, and third is through mode. The deviation through mean, deviation through median, deviation through mode. Then we find out the mean of those deviations. So all is called the mean absolute deviation, or in the symbolically we write MAD. Okay. So after getting it, just a moment. Resize the page and so in this mean absolute deviation, there were 3 demerits, 3 objections were there from the mathematician and the statistician. The first objection was that there is no fixed central tendency. There is no standard central tendency. Got it? First objection was that. Second, to convert negative into positive, arithmetically it is right, absolute value, but algebraically we could not consider it. So algebraically, to convert negative into positive, with modulus is not right. Got it? And the third was that if you are finding the, I explain you first one thing. Suppose this we have, and I am making few bar plots here. This is the bar plot. So these are the marks of the students of the section A class, section B, and section C. These are the marks, the average marks of the students. Here we are getting the average marks 45. Here we are getting the 65. Here we are getting the 52 marks average. And if we are finding out the mean absolute deviation of this, so here the mean absolute deviation is it is positive always, mean absolute deviation. So we get only the one-sided deviation. Here is a 7 deviation. Here we get the 8 deviation something. And here we get the 4 deviation. So it is only one direction. No, it is not negative side. So because we get the deviation in the positive direction only. So it is the unidirectional. Got it? Does that make sense to everyone? So after getting these 3 demerits, so they have decided to make one standard formula, or they have given the name standard deviation. And in this standard deviation, what they have done, they have first they have selected that the deviation should be taken only from mean. So mean is finalized now. Deviation will not be taken in the standard deviation by median and mode. It will be taken out through the mean only. Second, they have done that we will not use the absolute value. One more reason we have, if you have the -2, and if you make the square of this, you will get 4. And if you make the square of 2, you will get also 4. So they will square the deviation. Square the deviation. And third, in the both directional, they will square root the mean of the square of deviation. square root the mean of square of deviation. So I explain, you could better understand it. What they are doing, they are xi minus x bar, and they are just making the square of this, and they are getting the summation then divided by the n. So it is the not the mean of deviation, it is the mean of square of deviation. Does that make sense to everyone? And finally, they have taken the square root of this. And whenever you get the square root, you will get the plus and minus sign. And that's it. That is a standard deviation. So it is in the bidirectional. We have now the deviation in the both direction on the downward also. Does that make sense to everyone? Yes. Yes, I am not getting any response from your side. Okay. So this is the standard deviation. Now there is a variance also. Variance is nothing, it is the square of standard deviation. Okay. Now let me talk about the coefficient of standard deviation and coefficient of variance. The coefficient of standard deviation is sigma over x bar, and the coefficient of variance is sigma over x bar into 100. Sometimes we put percent also. So there is always sigma in the both the cases, coefficient of standard deviation, the coefficient of variance. And I will more tell you about this coefficient of these all. So coefficient of mean absolute deviation through this, so this is x bar, here delta me over me, here delta z over j. Got it? Yes. Does that make sense to everyone? Now, I will explain you about the, this we have covered the all thing about the measure of dispersion. We have just see the concept. No, we don't to go in the detail about the formula and these all things, direct method, indirect method, so many things are there that is not required in the R. And here we are going to use the correlation analysis now. That is the bivariate analysis. The measure of central tendency and the measure of dispersion is the univariate analysis. Okay. And the correlation analysis is a bivariate analysis, or the multivariate. Sometimes we use the partial correlation, but we'll not go in the deep. We just see the concept of the correlation here. Later on, when we do the in advanced part, then I will explain you in detail about the correlation. So I will explain you about the correlation. I just make now I explain you that this is our x-axis and this is our y-axis and this is our origin. Here also, and the other graph x and y and origin. Here also x, y and origin. I'm plotting few points here. Suppose first I explain you the correlation and with some example. We take the example of speed, distance, and time. Okay. So first we consider the example of distance and time. So we are taking the distance and the time to where the speed is constant here. Speed is constant. Okay. So if you increase the distance, the time will increase or decrease?
It will decrease.
Hmm?
It will decrease. Time
You are going from, suppose you are going from
It is linearly increase, sir.
if the distance is increased, the time will increase or not?
Time increase, distance increase with respect to time.
I explained that. Suppose the speed is 40 kilometer per hour. Okay. And the distance is 200 kilometer. How much time it will take?
5 hours.
5 hours. If you have 400 kilometer, then
10 hours.
10 hours. And if you have 600 kilometer, then
15 hours.
15 hours. So as the distance is increasing, the time is also increasing or not?
Yes, sir.
Both in the same direction. Na? As the distance increasing, time is increasing. Distance decrease, time will decrease. Got it? This is the distance, this is the time. This is the distance, this is the time. Got it? Both should be in the same direction. Okay. So that is a positive correlation between distance and time. If the one variable values are increasing, the other is also increasing. Does that make sense to everyone? May not be in the same proportion. Proportion may be not same, but they are increasing. Okay. So if X is increasing, Y is also increasing. Like this way. We are plotting the X and Y coordinates here. We are getting this sort of trend. So it is the positive trend because the X is increasing, Y is also increasing. Does that make sense to everyone?
Yes.
So through the visualization, we could easily understand the trend, which is the positive correlated or the negative correlated. Are you agree with me? If this the trend is like this, suppose I explain you one more thing. Now we are taking distance constant. And we are taking the speed and time. Okay. So suppose you have to cover a distance of 200 kilometers. That is fixed. And if somebody is going through the 20 kilometer per hour speed, how much time it will take to cover this 200 kilometer distance? Yes.
10 hours, sir.
10 hours. If he increase the speed by 40 kilometer per hour, then
5 hours.
5 hours. And it increased by the 50 kilometer per hour, then
4 hours.
4 hours. So as the speed is increasing, the time is decreasing or not?
Yes, sir. Correlation is negative.
Negative. So the one thing is increasing, the other variable values are decreasing. Got it? Or
Yes,
one is the first decrease, then the other will increase, the vice versa. Got it?
Yes, sir.
So that is the negative correlation. Got it? So I plot these points here also. So it is the X is increasing, the Y is decreasing. It will get this sort of trend. X is increasing with the value of Y is decreasing. Getting it?
Yes, sir.
As X is increasing, Y is decreasing. The value of Y corresponding to X is lower. The X is increasing, Y is decreasing. So this is a negative correlation. This is a positive correlation. So it is called the positive correlation or it is called the negative correlation. Suppose if these all points lie on the same line and they are not scattered like this. Understand? I just remove these points from here. These all lie on this line. The inclination of line may be anything. There is no, don't worry about the inclination of the line. But these all points lie on this line. Got it? Is it clear? Then it is a perfect positive correlation. Got it? This sort of correlation is called the perfect positive correlation. But in real time scenario, real life examples, it is not possible except pure science. Got it? Similarly, if these all points lie on the same line, these all points lie on this line, so it is the perfect negative correlation. Does that make sense to everyone? Yes. And if we have the points like this, we are not getting any sort of trend. So there is no correlation. Got it? Does that make sense to everyone? Now the correlation, we have a various measurement of the correlation, the coefficient of correlation. Here we measure not the correlation. We use the coefficient of correlation. Why we use the coefficient of correlation? Can somebody explain me? Yesterday I have explained you about the coefficients of range and these all things. Yes. Why we could not measure the correlation? We just measure the coefficient of correlation. Why?
The correlation is high, then we have the less value, and if the correlation is low, then we have the higher value. That is why.
To find the relative measure, how it is related,
Correct.
positively or negatively.
Correct, Roop. You are right. It is the relative measure. We are getting the relation between two variables. Got it? It is not an absolute measure. Yesterday I explained you about the coefficients, why we use the coefficient for the relative measurement. So here the correlation is already a relative measure. We are getting out the relation between two variables. So it is a relative measure, so we find out the correlation coefficients. There are various correlation coefficients we have. The Carl Pearson will not go in deep at this moment. Spearman's rank correlation, Kendall, tau, AB, whatever, on the BC and whatever the correlation we could find. But all the correlation values lies between -1 and 1. Okay. So how do we interpret these values? I explain you that. We have here our minimum value, or not the minimum. Here is the -1 correlation. Here is the +1 correlation. So is the perfect negative? It is a perfect negative. -1 is a perfect negative. Or +1 is the perfect positive. Whenever you get this value +1, you could write there the perfect positive. Okay. Here we have the 0 value, and this is the no correlation. Does that make sense to everyone? Here we have 0.25. Here we have positive 0.75. So the correlation between 0 and 0.25 in the positive direction, it is the low degree positive correlation. It is called the low degree positive correlation. And if you get the correlation between 0.25 and 0.75, it is the moderately positive correlation. And if you get the correlation between 0.75 and 1, okay, so that is the high degree positive correlation. Does that make sense to everyone?
Yes.
Similarly, in the negative side also, so it is the our low degree negative. This is the moderately negative, and this is our high degree negative. Got it? Does that make sense to everyone? Is there any doubt now in this perspective? Okay, so this was all about the theoretical part I explained you. Now we start the R practical, and I will explain you how to download and install R in your laptop or the system. So I will show you what you have to do. You just have to write down the download R program. And here you see the R 4.0.3 for the Windows. If you have the Windows, you have the other option, then you could go right there on the your search, Google search, you write the Mac or whatever the Linux you have, you could write over there and you get that version also. Okay, just click here, it will be downloaded in your system, then run it. And don't change the path of installation. It should be default, whatever it shows. You just next and do it. Does that make sense to everyone? Yes.
Yes.
And after installing it, what you have to do? Again, you have to install another IDE. This is the graphical user interface you are getting with this. You will get this R, the console, and you will write the command here. It is not interactive one. Okay, you will get this graphical user interface. Okay, and you require one IDE which is very interactive and where we will work. That is the R Studio. So you have to download the R Studio. There rstudio.com file, sorry, URL. Here you see the cran.r-project.org. This you could write, and you could then go into the path and you will choose that thing. Here we have the R Studio Desktop, R Studio Desktop Pro, R Studio Server, R Studio Server, because the R programming language is open source. IDE is partially open source. In the R Studio, you will integrate all the R tools, but you will not get the priority support. You could write on the forum and you will get the answer. The other community members of the forum will reply it. Okay. So R Studio professional drivers we will not get here. That will not affect on your work. Don't worry. You just have to download this R Studio Desktop free. You just click on here and then you will get, or you could go here and you could download it. After downloading it, you have to run it also and then install it, and don't change the path. And because both the R programming and the R Studio will integrate automatically if the path is correct. If you change the path, then you will get some problem in the integration. Does that make sense to everyone? So it will automatically integrate, and I will show you the R Studio will look like this. When you first time open it, you will get these three windows. Okay, 1, 2, 3. First time. This is our console window where we get the response whatever we write. This is our global environment, history, connections, and tutorials. Global environment, whatever the value we assign here, okay, that we get here. The x is equal to 5 and y is equal to 7, whatever we assign here, we get here. If I write the x is equal to 5 and I run it, so I'm getting here the value in the environment x is equal to 5. Whenever I will ask about the x, it will give me the value of 5. So that is the x, the value of x is 5. We have assigned the 5 as the value of x, and it is in my global environment. So this is our console. But in console, whenever you write something, you could not save it on a console. When you close the R Studio, it will remove from your system. It will not be there. It will be deleted automatically. So whenever we have to write something, we will use the script file. Okay, so script file is nothing. You see on the left side, we just click here, the R script, Control-Shift-N you could also use. And we are getting this script. If I write anything in the script, it will be saved on the real time. Got it? It will be saved on the real time. So I just, when I want to use some comment on the script, comment the statement or the things what you don't want the R would react on that thing, would not react on that particular thing. So that is a comment. Okay. So if I have to pass a comment, so I will use the hash. Okay. I will use the hash and I will pass any comment after hash. So R will not entertain that thing. Okay. So if I write a comment, first session. This is my comment. If I put my cursor here and I try to run it, it will not give me anything. You see, it is not reacting. R is not reacting here. If I write anything without comment, if I remove the comment here, if I remove the hash here, so it will not, it is not a comment now. And I run this. You see what I am getting here. I am getting an unexpected error. So R will react on this. So whenever you have to write a command, use the hash and then type anything, R will not react. Is it clear to all? Yes. Yes, you must be interactive in the session.
Sir, yes.
You respond fast, so we could run the so fast. Okay. So this small thing you understand about the comment. Now, if somebody makes some comment on you, don't react. Ignore them. Just like that. If you use the hash, R will not react on that. Okay.
Sir, I have a query. Before coming to R, you mentioned three types of correlation: Pearson, Spearman, and Pendleton. Where we applied, which one we applied? What is the applicability of different these?
Please, little loud you speak. Yes.
There are three types of correlation coefficients: Carl Pearson, Spearman, Pendleton.
Yeah.
Where we applied this correlation? In which type of data?
If you have the numeric value like age and income, suppose one variable is age and the other is a income or other is a weight, suppose the age and weight. Okay. Then you could apply the Carl Pearson. Understand?
Okay.
If you have the rank, you have a rank, you have a very few data, and like a discrete data you have, or you have the rank over there, then you use the Carl Pearson. Sorry, Spearman rank correlation. Spearman rank correlation. Okay. So that is the thing. And when we have the ordinal data like 1 to 5, the strongly agree, disagree in this type, we use the Kendall tau. Got it?
Okay.
We have the Likert type scale data, then we use the Kendall. Okay.
Okay.
So we will study this later on in our upcoming workshop. We study these all things in the detail. Okay. What is the difference between? Okay. These are the memo. These are our assignment sign. These are we use the assignment. These two symbols equal. The x equal to 5 I could write, and if I run it, I will get this in my environment. Or I could use one more. That is the alt and minus. Short key is alt minus. I will get this symbol. This is also for the assignment. So we have two options for the assignment. So if I write here, I will get the same. It will perform the same thing. Okay. Either you could use the equal sign or you could use this one for the assignment. But the good practice is called this one in R. But in Python only there is equal is a assignment sign. R we have two options. Okay. So now let me describe about how to create a project in R. Okay. Because whenever you do some work on R or in some work in some other programming language, you must keep that file in one folder, all the related files and whatever the stuffs with the files, the data and everything. You keep it in one folder. Basically, that folder is called a project. So how we could create a project? So I will explain you. You see on the right hand side, here you see the Deepa Jain's name is written here. I just click here, you have their new project name and you click on that and you click the new project. And I will write here the don't save. Take here, don't save, and it will take little time. So you see, I will get this pop-up window. And there's a new directory, existing directory, and version control. The version control we want to use. we have two options, the new directory and the existing directory. What does it mean by the new directory? Means you don't have any folder. You want to create a new folder that you want to use as a project. Got it? So that is the new directory. Directory means a folder here. So we just click here and we get this, the new project R package. So you just click on the new project and you write down the name of the directory, means the name of the folder. Okay. So I write the name, my first session. Okay. It is my folder name, or you could, if you don't want to use the hyphen or the underscore, you could write without that also. It is the folder name. And where you want to save it. So you could browse this. I want to save it on my desktop. Okay. So it is the path I have given. And use R environment with this project. I am not click on it. I will explain it later on. And create project. Up to here you understand what I have done. I don't have the folder for that project, so I am using the new project with the new directory. Okay.
Yes, sir.
And I create this project, and here you see my first session. This is my new project. In this new project file, I have the R history file. There is nothing because I have not done any work here. Okay. And I have the project file, R project. So I don't have to use it. It will be here only. Wherever in which folder you have this hexagonal R file, the R project file, it is a R project basically. You could open it. I will explain it, Manpreet, again. I will show you that project here on the desktop. I will show you on the desktop. My first session, you see. This 21, sorry, 21/10/2020. It was not my, where is another one? My first, so what I have saved it. Where is it? (2411) project I have created here. I just open it. It is a 2411. But there are a history of this of the last few days. So I just omit it. I will explain you again. I just omit it from here. And okay, because it is open in the R, so I will close this project first. And then I omit it from there. And then I again create, because it was already created. Again, I create that project. So I create a new project. Look at here again. We have to just click here and we are getting this, the new directory and new project. On the directory name, my first project. Okay. And on the desktop, project on the desktop. So I create this project. So it will take little time. It will be open here. It is my first project. And I will show you that desktop again. So it is my first project. So now if I click here, then you will see, just a moment. So here you see the 2411 and there is no history because we have not done anything there. Now it is okay, Manpreet? Is it clear to you? Yes. So this we have created, and whatever the file related to this project, you could put in that folder, or you could direct access from this folder, okay, those files. Here I am making one script file, which is I'm giving something XYZ. Okay, then whatever, and I will work on it. And suppose I have run here x is equal to 5 and y is equal to 7, and x plus y I want to see. I run these all together, because without running I will not get the output here. If you just enter here, it will not run. Enter will work like a Microsoft Word and a file. It will just enter and you will get the cursor down. But if you have to run it, you select it and run. Or you have another option, control enter. If you have to run any command, you could use the control then enter altogether. Control enter. Note it down. So this you get the x plus y is 12. Now I close it without saving. I am not saving anything. Even I have not given the file name. It is the entitled one. I have not saved anything. I just close it. And I say don't save also. Don't save. It will not, we will not get this thing next time when I open this project. I will not get x is equal to 5 and the y is equal to 7, because it will not save my workspace. So I put here don't save. Now second time I want to open this project. I could use the R Studio, or I could go to the folder and I just click on this R project file, this hexagonal R file. I just double click here. The R Studio will automatically open with the same project. Got it? You got my first project. But we have not anything in the global environment, but we have whatever I have written on the script, it is there. It has been saved in the real time. Got it? So this is the specialty of all the IDEs. And then like the Python, you use the Jupyter, everything. So it will save on the real time. Okay. So whenever the next time you will open, you will get it. If you want what I have done the last time, so you will see the history here. Getting the history? This we have done here. Or you could see the history here also. The history file, .history file will open here. Got it? So you will see the history here. The connections I will explain you later. Here the files, whatever the files in your folder, you will see here, all the files. But don't delete any file from here. If you click and delete this file from here, it will be removed from your system. Okay? So don't do that sort of mistake from here. Here you will see the plots, whatever the plot we will produce, you will see here. We could view here. These are the packages, the few packages you will get in default with R Studio. And some of the packages you have to install later on. So I will explain you later on how to install the packages. These are the help, you could write anything, whatever the requirement you have, you could get that thing here. This is the viewer. Viewer is for the interactive graphs. That is for the interactive visualization. Dynamic, we could say the visualization. And plots is for the static visualization. Okay, this is the difference between both. So I will show you a histogram. simple histogram of the normal distribution, 1000 observation, whose mean is 0 and the standard deviation is 1. Got it? The random normal distribution I have chosen because the random normal distribution in default you will get the mean 0 and the standard deviation 1. So this histogram we could see here in the plot. And whatever the figure you will make, you will see here. I could also make a box plot for this. This is a box plot. Okay. So we'll see how to create the visualization, these all things later on. And this I explained you just. So are you aware about how to create a project with a new folder? Box plot we use for, it gives us the range. I will explain you later on these all things in the visualization part. It is with the variable, this is the minimum value, this is the maximum value, this is the median, this is the first quartile, this is the third quartile. So it gives the idea about our variable. Okay. Does that make sense to you now? It is used for the continuous variable. It is being used for the continuous variable. Now, I will explain one more option for creating a new project. If you have already a folder, suppose you have already a folder and you want to create one project over there. So first we create some folder somewhere. I create a folder on the desktop, and new, this is my new folder. I remove these all items from here. Okay. So this folder name is new folder. Okay. And I just again go to the new project and don't save for this project. I don't want to save the things. And I'm using the existing directory. In the last time I have used the new directory because I want to create a new folder over there. Here I don't want to create a folder. Folder is already there. But I want to convert that folder in a R project. Does that make sense to everyone? Yes?
Yes, sir.
I just click on this. Then there is no need to write the name because the folder is always with some name. Okay. I will just see the path what I want. It is on the desktop. I will browse that project. I will browse that project, that folder on the desktop. So new folder, I will click. So this I got here. I browse that folder. Does that make sense to everyone up to here? Where to browse it? Up to that folder. And then create project. You will see it is a new folder. Does that make sense to everyone now? Okay. I think this file is already there in the desktop. Some file is there or not? No. Why it is there? I don't know. Why it is there? It should not be there. The last time, don't say. So we get this.
Sir, maybe when we start working, we'll be more clear.
Yes. So got it? How to create the project with the existing folder and with the new folder. Okay. Because sometimes we work with many projects simultaneously. Okay. With the many sort of analysis with the different projects. So we always use the project. Okay, because you see, I always use some projects for the various works. If you see here, analysis jobs, the PhD work, I have a project. Okay, you will see the project files there. Some you will see here the project file, and you will see here a project file also. So you will get the project file. So I have add every this folder as a R projects. Even our chapters also. If you see our course, that is also a kind of project. So I will get these all files over there. Does that make sense to everyone? I will show you that here. If I just start the open project and I will browse it, and I will go to our Cypher Analytica, then I will go to the data science with R, and I will go to the R fundamentals, and I will just click here on this project symbol icon, and I will get that project. And you see I am getting the all files here on that project. Got it? All the script files and everything. This is a good way to do. If you want to remove this, all the things, whatever in your global environment, you could use this brush. You could remove this, whatever in your global environment. You could close the these all, whatever you have. So up to here, you understand how to download our programming, how to download our studio, how to create a project, how to write a comment. Up to here, you understand. Now we start to learn the data types in R. Every language has its own built-in data types. Now, every programming languages. R has on its data types, and which we study here. So what data types we will study here, I'll explain you. Data types of R. So we study the data types. First is vector. Vector is our first data type. I will explain later on what is vector. I just opened my script, and you could it will save over time. So I will use that. So it would be better for you to understand the things here. You see the R core class 1. This is the script which I will share with you. The vector list matrix array data frame, and one more is there, that is the factor. There is some contradiction with the R community persons. Okay, some people think it is a factor is a data type, or some say it is a class. So I will explain you what is class. So vector is our first data type. Vectors are the most basic R data objects, and there are 6 types of atomic vectors. And the first is the logical, the integer, the numeric, okay, complex, character, and raw. Okay. So I have not written here the numeric, integer, double, complex, character, raw. Double and numeric both are same. Double and numeric both are same. So I have mentioned the double. But in the R basic, we see the numeric, and with some library, it mentioned double. Okay, both are same thing. There is no difference in both. So we learn here how to create a vector, and the single element vector first we create. Single element vector, when you write just one variable, one value in R, it becomes a vector of length 1 and belongs to the one of the above vector type. As we have written the x is equal to 5 and the y is equal to 7, this is the one element vector. So similarly, if I am writing the x is equal to 11 and I run it, so I will get here x is equal to 11 and I will see the class of x. So what is the class of this? So it is a numeric vector. Okay. The class of this vector is numeric. If I write the y is equal to 9 and I see the class is also numeric. Whenever we get the numeric class or the double class or the integer class, we could perform the arithmetical operation. Okay, if the class is character or the logical, we could not perform the arithmetical operation. Clear? So I just write the x plus y, x is 11, the y is 9, I will get the 20. X minus y, 2, x into y, 99, x divided by y is 1.222, and I want to round it off up to 2 decimal places. So there is a function round, x oblique y, and comma 2 means the 2 decimal places. If I write the 3, it will be 3 decimal places. Does that make sense to everyone?
Yes, sir.
If I want to make the exponent of x to the power 2, x is 11, 11 square would be 121. So it is 121. I have another option for that. I could use the cape button also. That just a moment. That is the x cape y, x cape 2. That is the 121. There is the exponent. For the exponent, you could use the double asterisk or you could use this cape. Does that make sense to everyone? Okay. Now there is a percent operator, and these are infix function basically. I will explain you later on when we study about the function. So percent. So x divided by y, x is 11, y is 9. So when we divide x by y, what remainder we get? When you divide 11 by 9, what would be the remainder? Yes. Yes. We get the 2 as a remainder. If we divide 11 by 9, 9 1 time 9, and we get the 2 as remainder. So we are getting 2 here. So this percent is function provides us the remainder. Okay. Got it? So this is a new function you are getting here. Percent. These operations, you know, this operator is a different operator used for the it gives us remainder. If you anything write between quotes may be single or the double quotes, it will convert in character. It will not be a number now. Whether it is a number or later, it will be a character. If you write in a quotes, it may be single quotes or the double quotes. Got it? Okay. So if I run it, and I will see it is the under quotes. And if I see the class, so I will not get a numeric class, I will get a character class. In the character class, we could not perform the arithmetical operation. Okay. If there is number in a quotes or it is a character format, and then we want to use that as a numeric, so we could convert them in numeric, or we have the s dot function, s dot numeric x. So if I convert because it is a number or it is in quotes or it is a class as character, now I convert them in numeric and I will see the class. Now the class is numeric. If I show you the x, you will get the without quotes. You see there is no quotes now. Now you could perform arithmetical operation over here. For the words or the letters, we could use the quotes always. Okay. So here I will show you it is always character, or this is the true. If I write, it is a logical. Yeah, true and false. So if I run it and I will show you the class is the logical. Suppose I assign x is equal to 7 and I have given the x 7 value. And if I put the x is greater than 5, so what would be the response of this? True or false? X is 7, and if I asking x is greater than 5, it would be true or false? True, correct. So I will get the true response. It is a logical response, conditional statement. I save it in with some name. Okay, and I see the class of T. That is the logical class now. Got it? Does that make sense to everyone? Now, when you want to create a vector with more than one element, you should use C, small c, with the round bracket function. This function is called the combine, which means to combine the elements into a vector. Okay. So we are writing so many elements in a vector. Previously, we have studied the single vector. This is the multiple element vector, and we use in this way. So you will see here in the square bracket, you will see the position 1 to 5 position. There are 5 elements, and these are the values. These are the position always in the square bracket. Got it? And if I run this, and I will get 2, 4, 6, 7, 9. If I see the class is the numeric, and I could write in this way also. If I write the 6 to 100, so I will get the integer from 6 to 100. If I show you, you will get it here. Are you getting it? From 6 to 100, I am getting the integers. So the class of this would be integer. But I want to explain you what does it mean. So it shows the position of the first element is the 21st position. If you count, this is the first position is 6. The 26 has the 21st position. 46 has the 41 position. Does that make sense to everyone? Yes?
Yes, sir.
Now I will show you the class also. So it is the integer class if you write in this way. And there is no requirement of the C. Now I am making one vector of the words, that is the red, green, and yellow. I am giving the apple, the object name. Apple is equal to, so, and I will just write in. I will show you the class is the character. Is it clear to all? Yes. Suppose in the X 2, 4, 6, 7, 9, I want to access 6 only. So I will write the X and then I will take the square bracket and I will write the index number of that. The indexing in the R starts from 1. So 6 in the, what is the index of 6? Yes. Can somebody tell me the index of 6?
1.
1. Indexing starts with 1. The first, second, third, fourth, 5. So what is the index of 6? Third index? Third index. Got it? So sorry, this third key is the stuck always. So it is the 6. Are you getting in the console? It is 6. Okay. I could access through the index. Okay. And I want to change this value. Instead of 6, I want to put there 8. So I don't have to do anything. I just give a assign sign and I will put that value 8. And I run it. And then again I write the X and I will show you the X. So it's 2, 4, 8, 7, 9 now. Got it? Instead of 6, we are getting 8 there. So Bhangini, you have not understand the indexing. I will show you the indexing here, apple also. In apple, I want to access green. What index should I write? So Bhangi.
So 2.
Correct.
Okay. Yeah.
Got the indexing?
Yes, sir.
If I want to write instead of green something else, so I could assign that instead of green if I write the blue. So, but always when you write the letter, write in a quotes. Either it may be single quote or it may be double quote. Okay. And
Okay.
now I will show you the apple. So you will see the red, blue, and yellow. Okay. Does that make sense to everyone? How to access the element from the vector? Is it clear to all?
Yes, sir.
So this is about the first data type, which is the vector. Second data type is a list. In the vector, we could not create a sub-vector inside a vector. And a vector is always independent, correct? So I will tell you one more thing. If I run this and I will show you the class of this, so you will say it is a numeric class, correct? Is it numeric class?
Yes, sir.
And if I write some number in quotes, only one element, write in quotes and run it. And I will show you the X. So you will see all numbers are in quotes now. Correct? There is only one number I have written in quotes. But in result, when I print it, I will get all in quotes and I will see the class. See what is the class now. So it is the character. It is not a numeric class. So wherever you put any element with quotes, it will convert the whole vector in character. Does that make sense to everyone?
Yes, sir.
So at that moment, you have to again convert them in numeric form. So how do you convert? S dot numeric function we will use. Okay. Now I will show you the X. So you will get without quotes and I will show you the class. It is the numeric. Got it? Okay. Is there any doubt?
No, sir.
Because list I would like to start from tomorrow. It's a big topic. Okay. List, matrix, arrays, and data frame, finally factor. So we'll cover these all data types tomorrow. And then we will start the basic syntax of R. That is in our next script. It is the first script. I will share this with you today because I have not shared any element, any data with the paid participants yesterday. I will share this all today. Okay. So you will get this all thing. And tomorrow we'll see the basic syntax of R, the basic functions we use in R. And we cover it day after tomorrow. So we'll finish this in 3 days. And later on in the last 2 days, 2-3 days, we'll cover that the descriptive analysis and everything. Okay?
Yes, sir.
So I hope you all are got what I have taught you. Okay. Is there any doubt, any query, any whatever you have in your mind, anything about data analytics, statistics, R, Python, whatever you would like to ask, you could ask me. Whatever the doubt, whatever you have.
Sir, we can calculate these correlation coefficients by R software.
Yes, yes, it's very easy. I will show
we
you.
will do.
I will show you. Don't worry. There is a one. There are few default data sets in R. Okay, I will share my screen first with you because I have stopped the sharing. Are you getting my screen now? Yes.
Yes, sir. Yes.
So there are few default data sets in R that is for practice purpose. So if you want to see how many data sets in R, you just write the data and use the blank round brackets and you just click, you will get the data sets name. Okay, these are all the data sets we have. So I am using one of the data set that's name, data set name is the empty cars. Okay, so I will show you that empty cars data set here. This empty cars data set I'm going to use. Okay, so what I have to do, I will write the some object name to that empty cars data set. I will give some object name here in R and it should be very abbreviated, very small data set, a small name. Anna? So generally I use somebody use the DF data frame. Somebody use the my data, but I use mostly the MD. MD is also the short form of my data. MD. MD and DF, this sort of I will use mostly. So MD, I write the empty cars and I run it. You will see here in the global environment. It will show you the 32 observation and 11 variables. 11 variables means the 11 columns are there and 32 observations mean the rows are there. Does that make sense to everyone? If you want to view this data, you just click here, you will get this data here. Got it? These are the names of the car and you want to know what this data about. So you just put a question mark first and then write the empty cars. You run it. You will get here. I will show you on the whole screen. You will see a motor trend car road test. Data was extracted from the 1974 Motor Trend US magazine. The comprises fuel consumption and 10 aspects of the automobile design, the performance of 32 automobiles. And these are the variables specification. The MP is the miles per US gallon, cylinder number of cylinders in the car, displacement cubic inch of the piston, horsepower, gross horsepower of the car, draw the rear axle ratio, the weight 1000 pounds in, and the Q-sack is the 1/4 mile time, and the VS is the type of engine, the V-shaped engine and the straight engine, the 0 for the V-shaped engine, 1 for the straight engine. Transmission is the gear transmission is the automatic and the manual, 0 for the automatic, 1 for the manual. And the gear, the number of forward gears, because the reverse gear is always 1 in all of the vehicles. And the carburetor, the number of carburetors are there. So this is the data set we use in the subsequent our classes also. So I will show you how to find out the correlated. I just
Ordinal data.
it is the default data set. There are so many data set like the Titanic data set, how many survivors were there, and these all things you will get. Arthritis data set. There are so many data sets in R. For the different learning purpose, we could apply this data set. We could use it. So I will show you the structure of that data set. STR for the structure of the MD. So these are the structure. It will give the class of the variable. It is the numeric. All variables are the numeric class. Got it? So I want to see the correlation between mileage and horsepower. Got it? Or mileage or weight. You know that if you increase the weight of the car, mileage will increase or decrease?
Decrease.
Decrease. Okay. Negative correlation. So I will see it. We see it. What I do, I find out the correlation. First, I have to write down the name of the data frame, MD. Then I will use the $sign. And when I apply the $sign, I will get the drop-down menu of all the variables in the data sets. Okay. Then I select one, mileage, and the second I am selecting MD $weight. Understand? I see the correlation is, the coefficient of correlation is minus 0.867. It's the high degree negative correlation. Got it? Between mileage and weight. In default, it is the Carl Pearson correlation. If you want to know the syntax of this, What are the attributes? So you just write the core with question mark. Put the question mark first. You see the correlation variance covariance matrices, COR, core. It is the states, it is the default package we get here. It is the for the correlation X and Y. And use everything. The method is we are using the in default, we are using the, here I will show you the character string indicating which correlation coefficient or covariance is to completed. One of the Pearson default, the Pearson correlation is the default one. Kendall and the Spearman we could write if you want. Understand? If you want Spearman, so you have to write here. I will just show you how to write it. You have to mention the method equal to, and in quotes you have to write, and the single or double quotes. You could write the Kendall. The Kendall. You want to write the Spearman, you could write the Spearman. Okay. Got it? You could perform the correlation test also, where we use the t-test formula. So the core dot test you could write with the MD dollar mileage, MD dollar weight. You could take any other variable also. So it will give the t value and the p degree of freedom. They are the 32 variables, and it is the between two. So n minus 2 would be the degree of freedom. 32 minus 2, it is 30. P value is less than 0.05. It is very near to 0. So there is no correlation between, it means our null hypothesis that there is no correlation between X and Y, and null hypothesis has been rejected because the value is less than 0.05. So there is significant correlation between mileage and weight. Got it? Does that make sense to everyone?
Yes.
I will explain you later on this all interpretation of these all things later on the R2, where we use the this inferential analysis part. Okay. So this is all about that. We could do. It's very easy. You have to find out the mean of any variable like the mileage. Just write, you will get the mean. If you want to find out the summary is SD, MD dollar, you are getting the SD. You get the summary of all also, all variables. You are getting the summary, 6-point summary of all variables here. Minimum value, the first quartile, the median, the mean, the third quartile, and the maximum value. You could get the more summary if you want. You have to use the some other library like the Cypher. This package you have to download. All packages are free. And whenever you import the library, you just write the library and the library name. It will now workable on your environment. Or you could apply the function of that library. Describe is a function of this library, and I apply on that on the MD. So you see, I will get the 12-point summary now instead of 6-point. Is the variable number 1 to 11 variables we have. It is the number of observations, 32 in each variable. The mean of each variable is given. Standard deviation of each variable is given. Median, the trimmed, the mean absolute deviation, minimum value, maximum value, range. Range is the maximum minus minimum. I explained is the skewness of the data cutoffs in the standard error. So you are getting the 12 points. Okay. So we get lots of things all together in R. Okay. So it's very easy to work with R. There is no need to learn any formula and anything. Just use the command, or the command is very simple. It is the simple terminology, because this language was prepared by the statistician or the mathematician, not by the technical person of the ITs. So the terminology is very simple. Like the statistics, where you learn the same terminology we use here. Does that make sense to everyone?
Yes, sir.
So let me call to Mr. Mukesh. Are you there? Mr. Mukesh?
Yes, sir.
Yes, sir.
So we are done for today, sir?
Yes, sir. Yes.
Okay. So let's meet again, everyone, tomorrow, same time, 5 o'clock. And those who have paid for the workshop, please make sure that you fill the form. Don't miss the form to fill up, because otherwise we will not able to share the study material. Those who have already paid will get the study material and video recording of the session. Just maybe today's session you will get by today night itself, or maybe max by tomorrow morning. All right. Thank you very much. Let's connect tomorrow again.
Okay, thanks, everyone.
Thank you, sir.
Thank you, sir.
Thank you, everyone. Thank you.
Thank you, sir.
Thank you,
Okay.
Doctor.
Thank you, sir.
Thank
Okay,
you.
it was a great lecture.
Thanks, everyone. Thanks.
Thank you.
Okay. Meet tomorrow.